Hey folks, welcome back to our channel. In this video, we are going to talk about GitOps. If you are new to GitOps, please watch this video till end. You will completely understand how GitOps works and what kind of problem does it solves. Before diving, what is GitOps? First, let's understand that if we want to apply something on Kubernetes cluster, what are the different ways do we have? And what are the challenges we have? Then it is better to talk about GitOps. First, see what are the different deployment ways we can do on Kubernetes cluster. If you want to deploy something on Kubernetes cluster, usually we can remember that it is a CI/CD pipeline, right? We just build and deploy it on the Kubernetes cluster by using the CI/CD pipeline. Next thing is we can install kubectl or Helm in our local system or wherever we have manifest files. From there we are going to apply. Usually we do it on our local system and we have manifest files on our local system. From there we apply. Let's see what's the problem with this approach. First, let's talk about the CI/CD workflow. If you see this workflow, we have a GitHub. Over here we have source code. So our source code is available over here. Git pulls our source code, build it, and then it is going to create image, right? So this is a Docker image because we are talking about microservices which deploys on the Kubernetes cluster. Once image is created, we are going to store it in the image registry. It is usually hub.docker.com, but it is a public. We don't use it. Mostly we use the ECR or ACR or whatever private repositories. Even in the Docker Hub also, we are going to use the private repository. So we store our image over here and we call this part as a CA. All right. Once CA is done, then we run the CD part. In the CD part, either we run the other job in the Jenkins itself. If it is your CA tool is a Jenkins. So here we run the CA and we run the CD over here. And to run the CD, we need to deploy this Docker image on the Kubernetes cluster, right? Obviously, we need manifest files. So our manifest files are configuration. So our manifest files or configuration files are available in the Git itself. Our CA or CD tool is going to pull it and it is going to deploy. So while deploying something like this, we have a step called deploy and it is going to run the command. We write the script for the deployment. This is the CI/CD workflow, right? Over here, if you talk about the problems, the first problem what we can see is the how do you roll back? Let's assume that you have deployed version 3 on your Kubernetes cluster, but somehow it is not working fine. Then how do you roll back? Obviously, you need to update your manifest file with the version 2 and you need to run the pipeline. Okay, either you need to run CI/CD both. This is CD, right? So CI/CD both, which is a time consuming process. Even if you want to do the CI also, you need to come and update it over here and you need to run it. Yeah, fair enough. Maybe if you have two different jobs for CI/CD, then it could be little more faster to recover or to go back to our previous version. But another challenge is how do you deploy infrastructure or platform level services like Prometheus, Grafana, ELK Stack, Kafka, Metric Server, for that matter, even ArgoCD. So some of the infrastructure and platform related services also we are going to use it, right? Obviously, those doesn't require any build because we are just going to pull those like Helm charts or customize and we are going to deploy it. So directly we need to do the deployment part over here. How do you do that one? So this is the challenge if you use the CI/CD workflow. Then let's talk about the another way, that is obviously kubectl. This is quite favorite way of doing deployments for most of the people. Over here, what we do, we have our local system and we are going to modify manifest file or config files according to whatever updates we wanted to do, and we are going to apply it in the Kubernetes cluster. This is the usually we use the command, right? kubectl apply -f and the file name. Even we can do it with the Helm charts, Helm install app and the charts and values, whatever changes we wanted to do. Apart from this, there are few other ways like customize and few other ways, but that's okay. So most of the cases, many people use the kubectl and Helm. Let's talk about it. Over here, we can able to deploy it. The problem with this approach is how do you know who changed what and when? Let's assume that you have a team of DevOps engineers. You wanted to do some changes on your Kubernetes cluster. You modified the manifest files and you did it. Okay, but you didn't communicate it with your team. How do they know? And how do they know that when this component has been changed and why it is changed? There is no proper reason. So tracking won't be there, and it is quite difficult for the auditing. Next, how to sync changes within the team. If you have a proper mechanism, then well and good. Or else it is quite difficult to sync your changes with your team. You applied something and you forgot to communicate with your team members. Even they might do something like that, or they have done some changes because of your updates, because you don't have the same changes in your manifest files. Whatever changes they have done, it might get reverted. So there is a challenge to sync your changes with the team and vice versa. Then how do you avoid manual changes? So you are directly interacting with the cluster. Manually, you are updating the cluster. But I don't think so it is a better way. If we avoid, that would be good. But is there any way? Because obviously you need to connect with our cluster. Otherwise, it is difficult to do the changes with this approach. Then, how do you avoid configuration drift? Configuration drift, nothing but whatever is deployed in the Kubernetes cluster, same thing is updated in your manifest files. But you have a group of team, each one have their own version of manifest files. If there is no proper syncing way, there is definitely a configuration drift. So avoiding over here could be challenging. Then how do you manage different cluster access? So this is bit advanced, but let me explain it. So let's assume that you have three clusters, one, two, three. So you want to apply changes on the cluster one. So obviously you should have the credentials of cluster over here on your local system. You have the credentials of cluster one. Similar way, you are also managing cluster two and cluster three as well. So in this case, what it happens, even you need to update the credentials of two, credentials of three. Okay, but every time if you are applying changes, you need to first set up the context. Okay, otherwise whatever default context is there, let's assume that default, by default, whatever changes I am going to apply it on the cluster one. So if you don't set up the context, it go with the default. By default you are applying your changes, but actually you want to apply it in the cluster 3. Because of this, there is a chance for the human errors. So these are the some of the challenges which we frequently face in the real world. Now, how do we avoid these changes? I just listed out the whatever challenges we have. Okay, so if we talk about the solution, let's assume that we have the developer, and I don't ask developer to do the changes directly on the Kubernetes cluster. Rather than that, whatever manifest files you have, just update those manifest files in the GitHub with whatever changes you wanted to do on the Kubernetes cluster. Only manifest files has been changed and committed into the GitHub. And GitHub has to apply those on the Kubernetes cluster, but GitHub doesn't have that capacity, right? In between, I introduce a system. This system is going to do all the modifications to the cluster by looking at the configuration files which are available in the GitHub. This process we called as a GitOps. So through the GitOps, we are going to do the changes on the Kubernetes cluster with a intermediate system. Okay, that is the GitOps. And as a DevOps engineer or SRE, whoever you are, you don't do the any changes on Kubernetes cluster directly. Whatever changes you wanted to do, it should be updated in the manifest files and committed into the Git. So that first thing, there won't be configuration drift. Yeah, configuration drift. Yeah, there is no configuration drift. And we know who changed when and what. So this is what. And also rollback is quite easy, because let's assume that you are running with version 3, and if you want to go back to version 2 because version 3 is not working fine, then just update the manifest file, you just commit it, and this system automatically monitors and changes it. We will see that one later how it happens in the upcoming video. But however, rollback is easy, and even we can deploy all the infrastructure and platform services, because we just pull those, modify it according to our environment and commit it into our GitHub, like Prometheus or Grafana. It is going to do that. And the next thing, How to sync changes with the team. Obviously, everything is available. If somebody want to do something, just they pull the changes from the GitHub latest manifest files and modify it and commit it. And how do you avoid manual changes? You are not directly interacting with the Kubernetes cluster at all. Okay, you are avoiding the manual changes. How to manage different cluster access? Okay, that can be taken care by this system. So most of the problems are solved with this solution. So that is GitOps. But one thing you just remember that if you have GitOps, you don't need the CD part in your pipeline because you do only CI, nothing but you build the image and the deployment is taken care by the GitOps. So now what is GitOps? If you ask me the proper definition, so here it is. So GitOps is a way of managing infra and app deployments using the Git. So if you want to do any deployments related to the infra or app, you are just going to do with the Git. I mean to say you just update the manifest files in the Git. So you store all configurations like Kubernetes YAML, Helm charts, even Terraform. Okay, we just committed it to the Git, and our GitOps tools is going to take care of from here. Any changes in the infra or app is made by changing the code in the Git. Okay, that is via pull requests, merge requests, not by running kubectl apply or clicking in a UI. So we don't do any manual changes. This we call it as a GitOps. Now, how do we achieve the GitOps workflow? That is where the GitOps tools comes. The popular GitOps tools are ArgoCD and FluxCD. We are going to talk more about ArgoCD because this is one of the popular GitOps tool to do the deployments, and how we can use GitOps for the application deployment. I'm going to show you in the next video. I hope this video is helpful. In next video, we are going to talk about ArgoCD and see you over there.